So here's the question I got on the MTTC test. It said, what is the distance from -2, 2, so a point on the coordinate plane, to -8, -7? And here's what I said to myself. I said, wow, I learned an equation in 8th grade called the distance formula. I remember the name, and I knew how to do it. I got an A on the test. I have no idea what it was. So I could have just guessed, right? Guessed an answer. Been like, oh, it kind of looks like this. So the first thing I did was I did this. I was like, okay, let's take a look. I want to take a look and see what this looks like on a coordinate plane. So I made a little coordinate plane on my test. You know, they had some scrap paper for us to use. So I make my coordinate plane. I go -2, 2. I went to -8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. I went to -7. I connected them, and I was like, okay. So I could kind of count this, right, and estimate. I forget what my estimate was, but there was like 2 answers that were close. So I was like, that's not good enough. So I started doing other things on it. Like I think I made a box. And then when I made a box, I said, holy smokes. Look at this. All that is the hypotenuse of a right triangle. And I was like, I remember this equation. And I was like, I think I'm in business. Like, this is not what it was trying to get me to do. But I think I'm gonna backwards get this. So then I counted 1, 2, 3, 4, 5, 6. Is that 7? Oh man, I plotted my point wrong. Okay, anyway. Maybe I did that too. Maybe I was like, oh man, I plotted my point wrong. I gotta go back and fix that quick. I was wondering why something wasn't working out for me. -2, 2 is right there. Nobody caught me, or did you guys just not? Just didn't want to hurt my feelings? All right, so here's our right triangle then. I made that right triangle. This really happened, guys. By the way, this isn't that poop pig thing. So this really happened. And so I had like 1, 2, 3, 4, 1, 2, 3, 4, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I was like, all right, I'm in business. 6 squared and 9 squared equals c squared. And I was like, you know, put that in my calculator, and I got square root of, well, maybe I should do this better. 117 is c squared. And I took the square root of 117, which would be the exact answer. We're going to learn something else related to that. But it was about 10.8. Okay? And here's the deal. I used that like one equation, but that wasn't the distance formula still. So I went back to my dorm. You know, we didn't have smartphones then. I'm not old, but we didn't have smartphones then. I went back to my dorm, went on my computer, and I looked up the distance formula. And here's the distance formula. Better believe I have it memorized now, and I'm going to tell you why. That's the distance formula. Now I want to show you something. Okay? I want to show you something. If I had the Pythagorean theorem, if I want to get c alone, how do I get rid of that square? Square root it. Which means the hypotenuse equals the square root of a squared plus b squared. Right? I want you to look at the distance formula and this formula and tell me some things you see in common.
They're the same. They're pretty much the same.
They are, in fact, the same exact thing. Or as some people like to say, samesies. All right? Anyway, so they don't look exactly the same, right? But let me show you why they're the same. So this is point -8, -7, and this is point -2, 2. So if I want to get that bottom leg, my horizontal leg, that's the difference in what values. What on a coordinate plane tells me left and right? X or Y? X tells me left and right. So if I take that -7 minus 2, I get, or sorry, that's the Y's. -2 plus 8, that gives me my 6. So guess what? In the distance formula, that's a 6 squared. What was it in the Pythagorean theorem? Okay. So if I want to find the vertical leg, that's the difference in which values? Y values. So negative 7 minus 2 is 9. Look at here. Now I know that's a negative 9. What's going to happen if you square negative 9 or if you square 9? Positive answer either way, right? All I'm trying to do here is not show you how to do it. I'm trying to prove to you that it is the Pythagorean theorem. Are you guys seeing that? If you take the difference in x's, it gives you your horizontal leg. If you take the difference in y's, that gives you your vertical leg. So, in my mind, as I try to recall the distance formula, in my mind I start with Pythagorean theorem, and then I say, how do I get my legs? I don't have x1, y1s, y2s flying around my head. What I have flying around my head is, how does this formula work? And then I generate the formula to do what I want it to do. Yeah. Let's look at a couple of different points. Let's look at 2, negative 6, and negative 10, negative 1. We're going to see how far apart these are, the distance. So remember, the hypotenuse is equal to the square root of a horizontal leg squared plus the vertical leg squared. Do you notice how I'm even using the words of what my equation's doing? Now, a lot of kids will get hung up on that x1, y1, y2 junk. All that is saying is, this is the first point, this is the second point. So those subscript numbers are just telling you, it's keeping us organized. First point, second point. That's all it is. There's no computational difference. It's just first point, second point. That's all that means. If there was a third point we're referencing, it'd be x3, y3. All right? So to get my distance, to get my horizontal leg, my difference in x's is going to be negative 10 minus 2, x2 minus x1. To get my vertical leg, it's going to be y2 minus y1, which is negative 1 plus 6. You might be asking, Mr. Mack, why are you writing plus 6 when it's minus? Well, that's a minus and negative. And I don't mess with minus negatives. It's addition. You can write minus negative if you want. You're just going to be more likely to make a mistake, I think. Are we good there? Oh, man, I didn't bring a calculator with me. So, 144 and 25 is all that is? You guys seeing that? 144 and 25. I got a calculator here. Well, maybe. I don't know if I do. So 144 and 25, that's 169. So the distance is the square root of 169, which is 13 units. There we go. Cool. Cool. Any questions about that one in particular, that distance? All right, now one other thing I want to show you. If you notice on the board, I have stretch goals. Remember back on that first problem, and maybe I'll set this up quick so we can just reference it. We had these 2 points, and we did negative 7 minus 2 squared plus negative 8 plus 2 squared. And we ended up with square root of 117. Do you remember that? Okay. Now, here's the thing that we're going to start practicing a little bit. When something's in a square root, it's called a radical. And we can simplify radicals. So you can get an estimate. What was that, 10.8? We said it's about 10.8. But we can simplify that radical with still keeping the exact answer. Because if we're going to use this distance in computation, we would still want an exact answer. Otherwise, we're going to get further and further away. So here's how you simplify a radical. You're looking for factors of 117 that are perfect squares. And here's what I mean by that. Numbers that are perfect squares are numbers that can be square rooted. So 4, 9, 16, 25, 36, 49, 6. You see what I'm saying? So as I'm looking at 117, and this is hard to know all the factors of 117, but there are some divisibility rules. I know by looking at 117 it's divisible by 9 because 7 plus 1 plus 1 is 9. And if you add the digits and it's divisible by 9, the number is divisible by 9. It's a divisibility rule of 9. It always works. So that means would you guys agree that I could do 9 times 13, and that'd be the same thing? Okay, so here's why that's powerful. I can then take the square root of 9. I can take the square root of 9 and get it outside of my square root. What's the square root of 9? 3. So 3 square roots of 13 is the same thing. And that is called the simplified radical. So I'm going to start introducing this. We're going to use it this year. This probably will not be on a quiz as we're doing the distance formula, but I'm going to start showing it to you because any of the math isn't new. It's just a new thing to do, right? So all I did was I busted up 117. I looked for a perfect square as a factor, and then I can take a square root of that factor. As I look at 13, is there another factor that's a perfect square in there? No, it's just 1 and 13, right? So that this would be the simplified radical, is what that would be called, the simplified radical. Cool, I think that's enough distance. Let's talk about the midpoint. So the midpoint, I'm going to draw a picture, and I just want you to understand what I'm doing when I draw the picture. We're not going to do any computation yet, okay? So in this picture, let's make a nice little coordinate plane here. And I'm going to make a line that goes from here to there. And I want to know the exact middle of this line. So you could like eye it, right? But here's what I like to think about. If I were to imagine a horizontal line going from there to there, halfway between the two x's would put me right there, right? Is that right? Nope, that's not right. 1 over. I almost had it. Okay. Halfway between would put me right there. And if I'm looking at the up and down, halfway up and down would put me right there. So do you guys kind of see where those two things cross? This spot right there? That is the midpoint. So halfway between the x's, halfway between the y's, kind of where those two things happen. What's another way to describe halfway between two numbers? It was like finding the something in math. You're close. Yeah, the mean or the average. It's like averaging my x values, averaging my y's, and finding where those two things meet, right? Are you seeing that? It's kind of averaging it out, left and right to the middle. So guys, that's all the midpoint formula is.
Wait, could
Check it out.
average them and that finds the middle point?
Yeah.
Oh, that's
If you add the x values and divide by 2, and you add the y values and divide by 2, that'll tell you the exact middle.
What's the sign in the middle between the two that you wrote?
That is a comma. It's an ordered pair. This equation is like an ordered pair. So let's actually take this line. So -3, 1, 2, 3, 4, 5. So 1, -1. So if we average the x values, -3 plus 1 over 2, and 5 plus -1 over 2, we would get point -1, 2. And guys, like magic, guess what that point is? -1, 2. And again, this equation, pretty difficult, I think, to memorize by letter and number. The x1s and y1s all floating around. In my head, all I start with is the average of the x's and the average of the y's. And that brings that formula to me. Does that make sense? That's why our goal today is, why does the equation work? If you can understand why it works, you'll be able to memorize it like forever. Anybody ever memorize something for a test and then forget it 2 weeks later? I've been there. It's called 90% of my college experience.
The mapping
Okay.
tests that we have to do.
Okay.
It's just like the 94 thing.
I don't want you to forget this. So let's practice just one more midpoint. I think midpoint's a tad easier. I don't know about you guys. So let's go from point 6, -10 to -6, -6. Again, average of the x values, average of the y values. That's all. That's how I had this memorized. So I got 6 plus -6 over 2. And I got -10 plus -6 over 2. And some people like to do this. Not a bad idea. Maths communication, as you get organized, things get easier. They'll label their ordered pairs. So I get a 0 and a -8. That's the midpoint, halfway between those two things. You're going to use this a ton in geometry next year to find things like perpendicular bisectors. You're going to use this kind of stuff along with some slope to determine if two lines are parallel. You're going to see if two lines are congruent on a coordinate plane. So you're going to be using this stuff a lot in geometry. All right? Cool, cool.